Okay, this is test 9. So we start off with matching. This is going to go way back to, chapter 10, 11. We'll start with chapter 10. So there's going to be a lot of review, but it's going to be a lot simpler too, because the equations are not going to be so hard if you remember. Anyway, number 1, a halogen used in the disinfection of drinking water, synthesis of medicine, crop protection, and PVC plastics. This halogen has a lot of uses. So look at your matching there. Which halogen would it be? One of the examples of PVC plastics are made of what? Chlorine, right? Chlorine we had a whole article on chlorine. So many things are made of chlorine, medicines and all kinds. So it would be C, chlorine. And chlorine is a halogen. If you look on the list, it's going to be halogen. The halogens are clear on the line of 17. Chlorine and fluorine are halogens. So, number 2, what is the most important element in the universe? You go, all the planets are full of it, and what is it? F, hydrogen. Planets are made of hydrogen, so if you look in the universe, it's hydrogen. So, but not in the earth, so the most important on earth is what? The crust is oxygen. So we'll get to that point. But anyway, number 3, noble gas. That's the last column of noble gas that do not like to have react. But this noble gas is used as lifting gas in airships and weather balloons. When you put this in a balloon, it goes poof. So which element is this? Helium, right? E, helium. Number 4, isotopes are commonly called protium, deuterium, and tritium. So what are these? Which element is this? Hydrogen, right? I guess you can use these twice because hydrogen again. F is hydrogen. Number 5, extracted from the air and used to make artificial fertilizers and explosives. Explosive like TNT and fertilizers are very important, and lightning puts it into the ground so that we can have this in the ground. And so what is it called? Nitrogen, right? Nitrogen fixing bacteria too in the ground that helps bring this nitrogen in and produce protein, amino acids. So H is nitrogen. 6, a gas found in the air that is necessary for survival of humans and animals. Which gas do we need? Oxygen, right? I is oxygen. Number 7, the ozone is a allotrope of this element. Ozone's the key. Which element? Again, oxygen. I, oxygen. Number 8, halogen, a halogen that's used in dental hygiene and in the manufacture of refrigerants. What do they put when you go to the dentist? They want to put on your teeth. And what do you brush your teeth with? Which one of those elements are dental? They're halogen. There's really 2 major halogens, chlorine and fluorine. So fluoride, right? So D would be fluorine. Number 9, exist in an unstable white allotrope and the more stable red allotrope, and it's used to make matches. Matches. Phosphorus, right? Phosphorus. Number 10, extracted from petroleum and natural gas by the Claus process, and this is the important that really tells me which it is. It's used to make important industrial acid. So the main element here makes this acid, and then we're very industrial because we have a lot of this acid, sulfuric acid. So it's going to be sulfur, K. Number 11, the science of extracting metals from ores and preparation for their use. This is the whole thing. So when you have ores and then you're trying to get the metals out of them, they call it metallurgy, metallurgy. Metallurgy. That's when you want to get the metals out of the ore. Metallurgy, like that. Urgy. So, number 12. Substances that dissolve in water to produce ions that can conduct electrical current are called what? So when you're drinking some Gatorade, what's in their Gatorade? Those ions in there that can even conduct electric current, they're called electrolytes, right? They're you could plug in electrolytes. Electrolytes, electrolytes. Number 13. The effects of changes on equilibrium systems are described as what principle? There's only one principle, and we talked about it, and that's the French one. And remember, it shifts to each side. So I call it le chatière, because it's kind of like shift and shaftier. So le meaning the in French, L-E, and then chatière, C-H-A-T-E-L-E, R-S, le chatière, the chatiers. Okay, let's go to number 14. The study of reaction rates and pathways are, it is chemical what? The movement of atoms, kinetics. K-E-N-E-T-I-C-S. Number 15. Kinetics is chemical energy. Kinetics is energy. Number 15. The minimum kinetic energy that a molecule must possess to undergo a chemical reaction is that what? Activation energy. To activate it into a new product. A substance that increases the rate of chemical reaction without being consumed in a reaction is what? It's called a catalyst. C-A-T-A-L-Y-S-T, catalyst. So like the catalytic converter or something, it's a catalyst. It helps to increase the rate so that more product's going to come, and it does a better job of getting at a lower temperature. So, or in a lower substance that increases the rate of it, it brings down the activation, how much energy it needs to use. Catalysts. Very important, like enzymes are catalysts. So let's go on to another matching here. Number 17, we're going back to these metals. So the alkali metal that's found in lye, washing soda, baking soda, and table salt. The key is table salt. What is table salt? Sodium chloride, right? So which alkali metal would it be? Sodium, right? L-sodium. The most abundant metal in the Earth's crust is a lightweight metal used to make aircraft, spacecraft, and even beverage cans. What are your soda cans made of? Aluminum, right? Aluminum. Number 9, and it's the most, aluminum. You would think, I asked Perry, what was the most abundant metal in the earth, and he'd say iron. And I said, no, it's aluminum. And he said, really? Aluminum. But aluminum's kind of hard to get out. But anyway, let's go on to number 19. The second most abundant metal in the Earth's crust, the cheapest and most widely used metal. The first was aluminum. The second, of course, is iron. So it's F, iron. And it's most things are made out of steel, which is an alloy of iron. So number 20, the most malleable and ductile metal known. Malleable means you can mold it into a lot of different things, and they make a lot of different things out of it. And you can even put it through wire ducts, but it's the most malleable. You know what it is? Gold. That's why we have a lot of gold jewelry, gold rings. You can it's very malleable, so it'd be E, gold. It's also a precious metal. Number 21, precious metal used in automobile and industrial catalysts. So there's like 3 precious metal, of course. One is gold, one is silver, and what is the third one? And the third one is what's used in an automobile. And it's even more precious sometimes and worth a lot more money even than gold now these days. It's an industrial catalyst. It's called platinum. Platinum is very precious. So H, platinum. Number 22, the most common semi-metal found in computer chips, glass, and sand. So you find this element in sand. So it's very plentiful in the earth. And it's also what I knew is, what do we make computer chips out of? And it's silicon, right? So it'd be J. Computer chips are made out of silicon, because silicon is a semi-metal. It's not really a metal and it's not a non-metal. It's a semi and it's silicon. Number 23, the metal most commonly refined by blast furnaces. So what do we use blast furnaces for? To change iron into steel, right? So I looked at the list, and of course steel is an alloy, so it's not element, but it would be iron, F, iron. So an alkaline metal that helps, composed of limestone, slaked lime, and cement. So limestone, that lime stuff is really chalky because it's filled with what? Calcium, right? Calcium is pretty chalky. Calcium is like your bones and your teeth and everything, kind of white. Well, limestone, well, that is because it has a lot of calcium. C, calcium. Number 25, a metal used in electrical wires as a component is also a component of brass and bronze. So what is mixed with, brass and bronze is mixed with zinc and, well, anyway, which one element that you mix with both of those is copper. And copper, they like to use copper in electrical wires all the time. So D, copper. Number 26, which of the following changes would not increase the rate of a chemical reaction? A, diluting the reactant concentration. B, grinding solid reactants. C, increasing the temperature. And D, introducing a catalyst. Which of the following would not increase the rate? So when you want to make a solution, what do? You stir it and you grind it up. Yep. And that would increase the rate of the reaction. Increasing the temperature, of course, the atoms are going to collide and increase the temperature would. And if you introduce a catalyst always increase the rate. So the only one is diluting. Diluting the reactant concentration would not. You wouldn't want to make the concentration less. You want the concentration more. So the one that is not would be A. A. Number 27, a solution that contains as much dissolved solutes as possible under equilibrium conditions is said to be what? So this is, what do you have when you're just totally full here? Is it a hypotonic, supersaturated, hypertonic, or saturated? When it's just full into that equilibrium, it's going to be saturated. Now, when you try to push more in, you can supersaturate it, but as much dissolved as possible for equilibrium, it's going to be desaturated. Number 28, the theory that when two molecules collide and chemically react, they form a short-lived activated complex before breaking apart to form the product is the what theory? So when two molecules collide and they react, what theory would you have here? Is it the transition state, the collision, kinetic, or the transformational form? So I would think it'd be the collision theory, although it may be the transition state, but I would, collision theory would be a good answer. So. Number 29, which of the following statements about catalysts is true? The overall change in enthalpy is lower for a catalyst reaction than for an uncatalyst reaction. B, catalysts in the same phase as the reactants are classified as enzymes. C, a catalyst shifts the equilibrium of a chemical reaction toward the products. Or D, A catalyst increases the reaction rate by lowering the reaction activated energy. So, which one does it happen? Well, first of all, there's no overall change in catalyst doesn't change the enthalpy. There's no overall, so it's not A. The catalyst, there are enzymes, but is catalyzed in the same phase as reactants are classified as enzyme? No. There are types of catalysts that are enzymes, but that has nothing to do with it. Number C, a catalyst shifts the equilibrium to the chemical reaction towards the products. No, catalyst never shifts anything. No shifts. So that has to be D. Catalyst does increase the reaction rate. We know that. Makes it more product, right? A lot of things like a catalytic converter and all these different things is important for the reaction rate. And it does lower the reaction activation energy, so it doesn't take so much energy, so it has to be D. Number 30. The rate of chemical reaction is usually measured as A, the heat produced per unit of time, B, the change in concentration of a given substance per unit of time, C, the total amount of products formed, D, the total amount of reactants formed. So let's look back. The rate of chemical reaction is measured. How do you measure it? You don't measure it by the heat, because you have, and you don't measure it by the products formed. You're going to measure it at the change in the concentration of the substance per time. So that's the one I'd pick, B. 31. In a solution of sodium chloride and water, water is what? So water is what they're dissolving in. So is water A, the solvent, B, the dispersing medium, C, the solute, or D, the dispersing substance? Well, the sodium chloride, the salt, is going to be the solute. But what is the water? Water is what you're dissolving it into, so it's going to be the solvent, A. So 31 is A. 32. Which of the following statements best describes a system at equilibrium? A, no matter is allowed to enter or leave the system. What's that about? B, concentrations of reactants and products are equal. C, rates of forward and reversal reactions are equal. D, the internal energy of a system is conserved. So which of the following statements best describes a system at equilibrium? The rates of forward and reversal are, if you go forward and reversal, they're going to be equal, and that will be equilibrium. So it'd have to be C. 33. The flow of a solvent through a semi-impermeable membrane from a more dilute solution to a more concentrated solution is a what process? Is it A, diffusion? Is it B, Brownian movement? Is it C, osmosis? Is it D, hydration? Of course, it's going to be the movement of water is going to be osmosis, C. That's an easy one. Basically water flowing through a semi-impermeable membrane is osmosis. Number 34. A mixture of two or more metals usually melted together is A, a colloid, B, a conglomerate, C, a suspension, or D, alloy. Which one has to do with, of those that have to do with metals? Well, it's not a colloid. Colloid are little particles in the, particles in the air or in something, colloids. Conglomerate, no. Suspension, suspended, no. An alloy. An alloy is melted metals together, and sometimes, like copper and zinc, you melt them together, you get bronze or something, or carbon and iron, you melt together and you get steel. It's an alloy, D. 35. A mixture containing tiny clumps or particles that remain suspended within the mixture and will not settle out. I hope you know that. A, colloid, B, conglomerate, C, suspension, D, alloy. Those are colloids that are suspended in tiny clumps in solutions that don't settle out. They're in there like smoke and stuff. 36. If the temperature of a chemical reaction is increased from 20 to 30 degrees, we would ordinarily expect the reaction rate to remain the same, increase by 50%, double, or triple. Remember, for each 10 degrees, it doubles. We did that before. So from 10 to 30 degrees is 10 degrees. It would double. C. Number 37. A nonpolar substance will be more likely to dissolve in a polar solvent than in a nonpolar solvent. False. Like dissolves in like. So a nonpolar substance will be more likely to dissolve in a polar? No. False. It would dissolve in a polar. So put polar, P-O-L-A-R. Number 38. A factor that causes a change in equilibrium system is called a disturbance. No. Well, it is a disturbance, but disturbance it's false. So what is it? A factor that causes the change in equilibrium is called a stress. Stresses it out. So S-T-R-E-S-S. Number 39. A protein catalyst found in living things are enzymes. Yep. Those enzymes in us are protein catalysts in us. So enzymes. Number 40. The energy diagram that you see there represents an endothermic reaction. So an endothermic reaction means basically it starts low on one side and then it goes higher. So it's actually taking in more energy on the reactant side. So is this one starting low and going high? Yes. So it's independent. It's exothermic. So if it goes lower than, it's going to be exothermic. So the energy diagram below represents endothermic reaction. Yes, it does. True. 41. If a non-volatile solute such as glucose is added to water, the boiling point will increase. Yeah, if you take salt and put it in, something's boiling, and you put more salt in it and everything, it's going to increase the boiling point. True. Number 42. When a gas is dissolved in water, decreasing the temperature tends to decrease the solubility of the gas. No, when a gas is dissolved in water, decreasing the temperature, so you're going to make the temperature lower, tends to increase. Usually as you decrease, it increases the solubility. So I would say increase. False. It has to be increase, not decrease. Number 43. A chemical system in which the rates of reaction in opposite directions have equalized so that the concentration of the reaction and the products is I can't even read it, in the state of chemical equilibrium. So a chemical system in which the rate of reaction in opposite directions have equalized so that the concentration of the reaction and products is in a state of chemical equilibrium. True. If they're equal on both sides, it's equilibrium. Number 44. Removing the hydrogen iodine as soon as it is formed would shift the equilibrium to which direction? Okay, let's talk about that. If you basically took the hydrogen iodine, that's the product, off, and removing it, it would shift to what? Basically removing the hydrogen iodine. So it doesn't have the equation there, I don't think. As soon as it is formed, so removing the hydrogen iodine as soon as it formed would shift to the right. Because if you're removing it, it's going to make more product. So you're going to make more product go to the right and to completion. Okay. So if you keep removing the product, it's going to shift to the right because it's going to keep going the direction to the right to get done. So number 45, increasing the pressure would shift the equilibrium to pressure doesn't shift equilibrium at all. So there would be no shift. When you have the pressure, it's going to be pressurized on the whole equation. So there's going to be no shift. C. Adding a catalyst to the system would cause the concentration of hydrogen iodine to what? Increase, decrease, or unchanged. Catalysts do not increase the concentration. They only increase the rate. So it would be unchanged. So number 47, increasing the temperature would shift the equilibrium to the, if you increase the temperature, what's going to happen? Increase the temperature would shift the equilibrium to which side? Increase the temperature would would go to, I think, the right. I'm not sure about that one. You can look that one up. Number 48, adding hydrogen to the system would cause the, you know what, in your book, a certain page, if you look in your book, you'll see there's a page that talks about temperature and shifting and such, which way it would shift on that. So increasing the temperature would be opposite. So it would shift it to the left, I guess. So number 48, adding hydrogen to the system would cause the concentration to what? So if you add hydrogen to it, the concentration is going to what? Increase, because you're going to add more, and it would cause the concentration to get thicker, so it would increase. That's a pretty easy one. Number 49, adding iodine vapor to the system would shift the equilibrium to, so if you add the iodine vapor to the situation, so you're adding more iodine to the system, it's going to shift it to the right, B. So more that you add of the reactant, it's going to shift it to the right. Removing hydrogen iodine from the system would cause the concentration of the iodine to what? If you remove the iodine from the system, this would cause the concentration to decrease, right? So, because you're removing that. So, 51, what is the molarity of a solution containing 6 moles of sodium chloride dissolved in 12 liters of water? So you have 6 moles and you have liters. You can keep it in liters and you keep it in moles. So you say 6 divided by 12 is like 1/2. And then you would change this 1/2 to 0.5. So 0.5 is 1/2. So it'd be A. For the reaction, that was pretty easy, just dividing 6 moles by 12 liters. That'd be 0.5 if you divided them. For the reaction of 3 irons, 3 Fe solids, plus 4 H2O gas on one side, then you have Fe3O4 and 4 hydrogens there. In which direction does this catalyst shift the equilibrium? So basically, for this reaction, what direction does adding a catalyst? Adding a catalyst doesn't shift ever. So you would say unchanged. It doesn't shift. So number 53. So let's see if we can get this finished. These last ones are getting a little more difficult, but it might take a little time. Number 53. For the reaction, and you have it there, AgH2C3O2 aqueous on one side, and then you have Ag aqueous there, and onto H2CO3 or C3O2 aqueous. So in which direction does the increase in pressure shift this equilibrium? So here, basically the shift, for this reason, which direction does the increase in pressure? Increase in pressure doesn't shift it either way. So it'd be unchanged. So it's kind of a trick. They give you this big problem. Increase in pressure is going to doesn't do anything to it. So number 54, which of the following would not cause the reaction? Here you have it all here to shift to the right. So allowing the hydrogen to escape. So if you allowed the hydrogen to escape, more hydrogen product there, it's going to shift to the right. Decreasing the concentration. If you're going to decrease the concentration on the right side there, it's going to shift to the right. If you're going to increase the concentration of hydrogen chloride on the left, that's going to actually shift it to the right. So D is increasing the pressure of the reaction chamber is not going to be a change. So it's going to have D. Your answer will be D. 55. Write the equilibrium constant expression for the reaction. Okay, so I'm going to stop there and finish up the problems so that you can see them on the next video. So because I think these you're going to have to show your work, and we'll just do the next few on the next video.